Welcome to If and Only If, an exploration of conditional logic in interactive fiction. As a quick introduction, I'm Grim Bakaris, and I'm a writer, game developer, and narrative designer. I've been making games since 2016, and I've worked on over 30 games both independently and for clients as a freelancer. One of my ongoing projects is the Twine Grimoire, a series of free digital resources for users of Twine, an open-source tool for telling interactive, nonlinear stories. I've been making tutorials and answering questions for fellow game devs since 2019, and I'm always learning a lot and finding new things to experiment with in Twine. While the Grimoire originally started with a focus on custom style sheets, or CSS, I've since branched out to taking requests from patrons and discussing other Twine-related topics like using macros and designing mechanics. Parts of the following talk are adapted from forthcoming volumes of the Grimoire. Many moons ago, I was in college taking an introductory course on logic for a math credit. I was, and remain, bad at math, but I figured I wouldn't have to encounter any numbers this way. The monkey's paw twitched to life. After struggling through some complex propositional proofs and some painful exams, I did end up passing the class, but it certainly reinforced my deep primal distrust of math. Then I started making games and things clicked. Variables and conditionals were the most accessible building blocks of that course, so I ended up having some helpful background knowledge when I decided that I wanted to make my games more complex using things like state tracking and multiple endings and inventory systems, all of which require variables and conditional logic. I've ended up using and developing these skills in almost every single one of the games I've worked on ever since. Conditional logic can be a significant part of game design, and it's useful for anyone interested in interactive narratives to have an idea of how it functions. This talk will explore how developers and players interface with conditional logic through multiple lenses. We're going to focus on technical application in Twine, but we'll also be touching on how to recognize conditional logic, the intersection of math and game design, and how conditionals can influence the player. You might be familiar with the concept of a variable in a mathematical context, like in algebra or trig class where x equals something you have to solve for. For our purposes, we don't have to solve for x. Instead, we're defining what x is and how it may change or vary. The Twine Cookbook defines a variable as a container for a value that can change. In Twine, it goes on, a variable is a way of storing and acting on data of some sort. Anything from a number to a series of characters can be stored in a variable. SugarCube's documentation also describes a variable as a bit of storage where you may stash a value for later use. Though the variable as a container is a great metaphor, bear in mind that it isn't exclusive, and several distinct variables can still contain or act upon the same object. You can also think of a variable as a name for a value, a way to categorize and describe data. Variables are assigned changeable values or data, which are used in order to remember and act upon specific data in your game under certain conditions. Variables allow you to track the state of certain elements of your game. They can allow you to set a character's name or pronouns, the status of an item or location, the amount of currency the player possesses, and many, many, many other things. Here are a few different types of variables to be aware of. A qualitative variable is a non-numerical variable that describes data which can be categorized, in other words, a quality. Examples of this kind of variable include eye color, occupation, emotion, and location. Notice how these examples represent categories, and their values can be things like colors, concepts, or names as opposed to numbers. Qualitative variables are primarily evaluated this way, using descriptive words or Boolean, true or false, values. On the other hand, if a variable represents something that you can add, subtract, or otherwise perform a mathematical computation with or upon, that's a quantitative variable. Quantitative variable examples include currency, amounts of resources, things like hit points, MP, status bars, fractions, decimals, integers, percentages, and passage of time. Quantitative variables are represented with numerals and can include things that can be mathematically affected. Many qualitative variables are nominal, meaning that they don't imply a hierarchy of value and they cannot be meaningfully put into an order. Qualitative nominal examples include name, gender, eye color, and hair color. Other than perhaps alphabetizing the values of any given set, you can't put variables like this into a coherent order of escalation or de-escalation. However, you could rethink some of the quantitative examples above using a simpler ordinal variable, which is a type of variable that implies or requires an order. Notice how in ordinal examples there's an observable order to the possible values, for instance from low to high or from poor to excellent. Even though some of these examples reference amounts or things which could otherwise be interpreted as quantities, they're being expressed via qualities here. Sometimes, in order to analyze data, numbers are assigned to qualitative variables, but this doesn't transform them into quantitative variables. This kind of data analysis method is to streamline that process by having simple numbers represent different data points, allowing the data to be evaluated and studied. As an example, if you were creating a game mechanic corresponding to the 5 senses, you might assign each sense variable an arbitrary numeric label between 1 and 5 in order to categorize the data. For instance, 1 represents the quality touch, 2 is assigned to sight, and so on. Variables can be considered characteristics of a thing. Let's think about eyes. When differentiating types of variables, think of things like this. Eye color is a qualitative variable with values like green and blue, whereas number of people with green eyes is a quantitative variable with a corresponding numeral. Here are a few other types of variables. A Boolean variable can have 2 possible values representing the 2 truth values. In other words, such a variable can only be either true or false. You may recognize this type of variable if you are like me and liked cheating at The Sims 2. Per SugarCube's documentation, but this is true of Harlow's as well, story variables are a part of the story history and exist for the lifetime of a playthrough session. Once created, a story variable can be accessed anytime and in any passage. This makes them accessible globally. Story variables are most ubiquitously used in Twine and begin with the $sign sigil. Less frequently used, but still very useful when necessary, temporary variables live up to their name in that they do not become part of the story history and only exist for the lifetime of the moment or turn that they're created in. This means that they're accessed locally by the passage that they're created within. Temporary variables begin with an underscore as their sigil. Before we move on to how to evaluate these variables, let's discuss the criteria for evaluation. A condition is a state of being. A conditional statement requires a certain condition to take effect. That could be something like, if the variable jacket has the value equipped, then you set freezing to false, and your character is no longer freezing to death. This makes the environment more evident to the player, defining it with these values and communicating consequences with conditionals. In any case, conditional logic depends on the evaluation of conditions and their effects on certain processes. A condition describes the state of something. For instance, the state of an item can be held or not held by the player. If the key has the value of held, it becomes possible to initiate the process of opening the door. In order to begin this process, in Twine at least, Twine has to start by evaluating whether or not the key is held. We'll explore how to do that more later. In a mathematical context, conditionals are also called if-then statements and symbolized by a P arrow Q, which is read as if P, then Q. We don't need to do a whole proof or truth table to make logic work in Twine, thankfully, but to make more sense out of this, if you were to apply this to the key/door mechanic, you could think of it this way. P is the required condition for Q. So we've established that key is the required condition to open the door. So P equals key being held, and Q equals door being open. So if the key is held, then the door will open. Interpreting conditionals verbally sometimes helps us straighten out the logic behind them. Here's a few other examples. If the tarnished key is in the player's inventory, then they can enter the library. If you don't eat, then you'll starve. If you have 10 gold coins and a sword, then you can buy a scabbard. If you run out of oxygen, then you'll start rapidly losing HP. Regardless of the engine they're made in or the budget behind them, a lot of games often contain some form of conditional logic. Here are a few examples from other games. In Baten Kitehouse, Eternal Wings in the Lost Ocean, there is a mechanic that involves aging your magnets, which are items in your inventory essentially. So through hours of real life playtime, they may age into other things. Fruit will rot, I believe grain can age into beer, other things like that. And in this particular case, the shampoo Magnus will become splendid hair after 336 real life hours logged on the game. It just shows you this interesting vibe of what to expect from this game. Like, there is that much to do and be done. There are these little hidden idiosyncrasies of, yeah, you have hair in your inventory so that it can unlock all the music in the game, and it slaps. Some other examples: Silent Hill 2, there's a puzzle where there's many puzzles where you essentially you solve something and you get the key to progression immediately after solving or as a result of solving that puzzle. Silent Hill is also a series known for having multiple endings, some of which require an item to unlock or a specific event, others of which require you to play the game in a certain way or to, whether that means using certain items, visiting certain locations, or responding to other characters in a specific way. Many other games also have conditionally governed multiple endings, such as Ebe and other RPG Maker classics like Witch's House, Off, Yume-Nikki, and many more. In my own game, Devotionalia, there are several qualities being tracked relating to the rituals that you conduct in the role of the priest. There is only one deadly fail state in the game, which occurs if you try to sacrifice a sacred animal. This is another example of using conditional logic to define consequences and atmosphere. Before you start evaluating variables, first they need to be established. It is always highly recommended that you initialize your variables, but what does this actually mean? Initialization allows you to set default values for all of your variables so they display correctly throughout the game. When your game first runs, it needs to know what to do with its variables. What should be their default values? This is up to you to program in. All variables need a default state, whether or not it seems obvious. If you want the player to start with a certain amount of money or resources, that will be a default that has to be initialized. If you want the player to have a customizable name or appearance, defaults will need to be set, which can later be changed by the player. When you don't initialize your variables, you can run into all kinds of frustrating issues where your logic doesn't work, your variables don't behave as expected, and wires in general end up getting crossed with errors in your text, and characters or items or various other things knowing or holding or doing things that they shouldn't. I also recommend writing out a list or making a spreadsheet to help keep track of your game's variables, especially if there are a lot of them. Variables are evaluated using operators. The operators in this section are also all probably familiar to you from some kind of math class, but in this context they're being used comparatively as a facet of a game's internal logic. The main ones we have here are equals, greater than, less than, greater than or equal to, and less than or equal to. When using operators like greater than or equal to, and etc., you can also use abbreviations like GT, LT, GTE, and LTE rather than operating symbols if you choose to. You can also phrase equals as is. Note that when using GTE and LTE, the is operator is not necessary. The is indicates strict equivalence, not a comparative value like GT and its cohort, so these shouldn't really mix. We also have the standard mathematical operators like plus, minus, multiplication, division, and parentheses. These are really the only ones you need. If you've seen integrals, Greek letters, and other things in logic, those have no relevance to Twine, and personally, I don't even know what they do in regular math. Sometimes you'll need to check multiple conditions at the same time. The Harlow story formats documentation notes that conditions can quickly become complicated. The best way to keep things straight, it recommends, is to use parentheses to group substatements and express order of operations. In some situations, you'll find it much more useful or efficient to evaluate two or more variables this way. For example, in order to solve a puzzle, the player may need to have multiple specific items in their inventory. The game will need to check the state of both. You can use the operators and or to join separate sub-expressions in the same conditional evaluation, which we'll look at shortly. When you're involving multiple conditions at once, make sure to think about what the statements actually mean in the whole evaluation. In a case involving and, All conditions must be true in order to return any text. If the player has fulfilled one condition but not the other, nothing will show here. You'll need to set up other conditionals and checks to account for other possibilities. Onto the technical application. This is where we jump into Twine. In Twine, variable names have to follow a specific format which ensures they'll be interpreted as variables and not as another kind of data. They're set apart from other data by a sigil. Variable names must have at least two characters, the sigil and a second character. The second character cannot be a numeral 0 through 9, but it can begin with any character from A to Z, upper, lowercase, an underscore, or even another $sign. I recommend keeping your variable names brief and informative. Long variable names are annoying to type out repeatedly, and vague variable names will inevitably confuse you and lead to bugs. I know this from experience. Different story formats in Twine use different syntax. In the sugar cube story format, macros occur within two sets of greater or less than symbols. The set macro begins with the word set, followed by the variable name, followed by an operator, followed by a value. Twine will now recognize that item as being held when you read it out that way. In Harlow, macros occur within parentheses but follow generally the same format, but setting and initializing variables is just the beginning. Once you've set a variable, you'll at some point need to check it. After you've set them, you can then evaluate variables and establish their effects with the if macro. Checking a variable means that the game is actively interpreting the value assigned to it for a specific reason. For example, if the player clicks a link labeled "Open the door," the game may need to first check whether or not the player is carrying the key that will open the door. If they are, the door will open. If not, the game should then nudge the player in the right direction by reminding them that the door requires a specific key they haven't yet discovered. Here's a demonstration, both Sugar Cube and Harlow, that shows a quantitative value being analyzed, whether or not you have enough gold to stay at an inn. Here's another example. Let's say you're making a game about a broke amnesiac who has lost their name, money, and items. You wouldn't want your variables to just return broken and undefined when you first reference them. So, you've set them like so. Then throughout your game, you'll want to evaluate certain qualities under certain circumstances, whether to add flavor for a mechanical reason, like monitoring the world state, or otherwise. You can interpret conditionals using the if macro, but sometimes you just want to directly reference a variable's current value in prose or dialogue. To do this, simply type sigil variable name, and Twine will print the current value in place of the variable name and sigil when playing or testing the game. As a simple example, here's an expansion on the name variable. This allows for a state in which the player does eventually recover a name, at which point NPCs and other characters will start referring to them that way. You don't necessarily need to use a separate if macro every time you're evaluating different variables. If two or more variables will affect the same condition, they can be combined into the same macro and evaluated simultaneously. Let's say the player needs to have found both a minute hand and an hour hand in order to solve a puzzle involving a clock. The three variables that are relevant in this situation are minute, hour, and clock, with the former two affecting the state of the latter. In both Sugar Cube and Harlow, if you want to check multiple variables in the same statement, each variable needs to be enclosed in parentheses. It's good practice to do this so that there's no ambiguity about which variable is which. Otherwise, you might run into errors, especially with more complex subgroups. If this example were written in an if-then format, it would read something like, if the player has the minute hand and the player has the hour hand, then the clock will be fixed. The else component of the evaluation accounts for the possibility that the player has fulfilled only one or none of the required conditions to fix the clock. Especially when working in the story format Harlow, keep an eye on your brackets and parentheses. It's easy to forget one, and missing a single one can result in an error. I've bolded all of them in this example so they're easier to see here. In other scenarios, you might find or a more useful operator than and. For instance, if the player's hair is black or brown, the text should describe it as dark. If it's blue or red, the text should say it's bright colored. Or if the hair's variable value is blonde or white, the text should call it pale. Here's another example. If the player has found any kind of light source in this scenario, like matches, a flashlight, or a lighter, Then they'll be able to navigate a dark room. Having talked a lot about Twine at this point, I'd like to bring up some other game-making tools you may want to try out if you're interested in this topic. Those include Bitsy, Ren'Py, Inform 7, ChoiceScript, Ink, RPG Maker, and many more. There is pretty limitless application here. You can set up conditional systems in a game engine or a paper game book. You know the ones. If you chose to fight the dragon, flip to page 72. If you fell in the spike pit, flip to page 104, that kind of vibe. I've discussed the developer side of this topic for a while now, so we're shifting focus to the realm of the player. In general, the word if represents uncertainty. It represents something that can be done but has yet to come to pass. If you do it, whatever it is, something will happen, but it could also be interesting to see what else happens if you don't do it, to explore the opposite notions by challenging the game logic to show you alternate paths and fail states. This is something I personally like to explore as a player. In many cases, conditionals are visible on screen. They govern systems and mechanics like health and inventory, and are represented in the UI, the HUD, the menu. Other times they are more subtle, made up of implications and inferences that are up to the player to investigate. While ambiguity can be narratively meaningful, there are also drawbacks to poorly realized conditionals. Having too many conditions to attend to can lead to choice fatigue, and having ill-defined ones leads to a lack of narrative or mechanical clarity. Manipulating variables to recognize player selections, even in moments of reflective choice, acknowledges the player, whether they are being presented with dire consequences or simply seeing their desires reflected within meaningful constraints. Impactful state tracking at its core, regardless of its scope, is facilitated by conditional logic. Through this logic, we set tonal expectations, then reinforce them through evaluation. To conclude, conditionals are an essential part of your toolkit as a developer and can facilitate a direct connection between the player and the game. Not all games require complex or any conditional logic in order to be impactful, fun, or challenging. However, all kinds of games can benefit from the effective application of conditional logic, or even from its mere implication or intentional absence. Logical constraints form the ways we teach our games to define and interpret themselves, as well as the ways we encourage players to interact with them. And to wrap up, here are the sources and software cited throughout this talk. Thank you so much for your time.